This is the 10.3 homework, problems number 6, 7, and 8. So for 6 and 7, we'll identify the wholes and asymptotes in each rational function. So for number 6, x plus 2, can't really do anything with that. Let's factor the denominator. So if we use xbox, 2 times negative 10 is negative 20, x squared. And then we have b is negative 1, so negative x. So we want to know what multiplies to be negative 20 and adds to be negative x, and that's negative 5x and 4x. So now we'll do the box. So we have 2x squared, 4x, negative 5x, and negative 10. GCFs, this will be x, this will be 2x, this will be negative 5, and this will be 2. So if we kind of check our work here, I always do that with negatives in particular. 2x times x is 2x squared. 2x times 2 is 4x. Negative 5 times x is negative 5x. And negative 5 times 2 is negative 10. So we're good. So if we rewrite our function, we now have x plus 2 over x plus 2 times 2x minus 5. This is an equivalent form of our function. Now we can see that we can actually cancel out the x plus 2's. And if you set x plus 2 equal to 0, you get x equals negative 2. So there's a hole at x equals negative 2. The 2x minus 5 is left in the denominator, and so that will create our asymptote. So if you set 2x minus 5 equal to 0, add 5, 2x equals 5, divide by 2, x equals 5 halves. That must be our asymptote. Moving on to number 7. We'll have to factor the numerator and denominator. Let's do the numerator first. We do xbox. This is a 1, so 1 times negative 21, AC x squared is negative 21x squared. Our b is negative 4, so negative 4x. So we want to know what adds to negative 4 and multiplies to be negative 21, and that will be negative 7x and 3x. Put that in our box. We have x squared, negative 21, 3x, negative 7x. Then we'll do our GCFs. We have an x, we have an x, we have a 3, and we have a negative 7. If we kind of check here, x times x is x squared, x times 3 is 3x, negative 7 times x is negative 7x, negative 7 times 3 is negative 21. Good. So now our numerator is actually x plus 3 times x minus 7. If we look at the denominator, there's only 2 terms, and they both have an x, so we can actually rewrite x squared minus 7x as x times x minus 7. So now we look for what cancels, if anything. And in this case, x minus 7 cancels out, because x minus 7 over x minus 7 equals 1, just like anything over itself equals 1. If you set x minus 7 equal to 0, you get x equals 7. So that's our hole. And now we look for anything remaining in the denominator, and we have an x. Set x equals 0 equal to 0, you just have x equals 0. So that's our asymptote. Finally, for problem number 8, we want to write a rational function with a hole at x equals 2 and an asymptote equals x at x equals negative 2. So we'll start with a fraction. And if it's a function, let's say f of x equals. Our hole is x equals 2. So if x equals 2, we subtract 2 on both sides. That means we'll get x minus 2 equal to 0. And so if it's a hole, it cancels. So we want an x minus 2 in the numerator and an x minus 2 in the denominator. We have an asymptote at x equals -2. Well, if x equals -2 and we add 2 to both sides, we get x plus 2 equals 0. And an asymptote is in the denominator and doesn't cancel. So here's our x plus 2. So f of x equals x minus 2 divided by x minus 2 times x plus 2.